Let's go ahead and get started. How's everyone doing today? Hi, everybody. Okay. Let me start with an apology. Normally when I create assignments, I create a program that I let you run so that you can kind of see how one works to work with. The program I wrote for this assignment was a piece of crap. Okay, it was literally the worst program I have ever written in the history of this entire class. There were so many bugs in it that it was atrocious, and I apologize. It's like a D program, so your program should be better than mine. I didn't have much time to write it, and I just wanted to apologize for that. People keep finding bugs, and there probably are still bugs. So, okay. So I apologize. The next one's going to be better. I put a lot more time into it, which means that it'll be better and harder. Before we get started, any questions? I know the program's due on Thursday. Any questions? No? Nothing? No questions? Yes, sir. Yeah. Okay, so the question is what to do when there's an error in the line, right? There's not going to be any type errors, but there might be errors in the range, like the number might be too big or too small. In that case, how do you treat it? The other section is essentially the other section of this class. When they encounter an error, they're just turning their program off. They're stopping. My preference for you is to go through and keep reading the file and point out other errors so that the user can fix them all at once. My program is supposed to compute the average of all the only good lines and skip the bad lines. So do something reasonable. Does that answer your question? So either read the line and tell everything and quit, read the line and don't use it in the average. It's a little more complicated to do it that way, but not by much. So if you look at the grading rubric should be pretty flexible on how to approach that. That was one of the things that we talked about, just the other instructor, because of the differences between the sections. Yes, sir.
If the line has more than one error,
yeah.
It is sufficient that, currently mine right now says the first error, and then it'll skip the next line, and then if they fix it, then the second error will.
Sure. I mean, it'd be preferable to find all the errors in the line at once. But since it's been poorly specified, do something reasonable. Okay? Sir?
In the output file, do you need the introductory message, or is it just the 4 lines, or the however many subject lines you have?
In the output file, do you need which introductory message?
Where the intro.
Oh, that says, that you're... No, you don't need that in the output file, just the output of numbers.
Subject 1, blank, subject 2, blank, that's all.
Yeah, exactly. Whatever the output that happens after you have entered the file name. Does that make sense? Other questions? Yeah?
I have a question about indentation.
We'll do that today. Absolutely. Yes?
Is there a standard error message?
No. I mean,
Also, how do you I don't know why, but C++ doesn't let you add strings.
no. Yeah, it does. What do you mean add strings? Concatenate with the plus sign?
Well, I was trying to add the values in the middle, and then it gave me a weird.
Because you can only add strings together. It won't. If you put a number, it won't convert the number to a string and add it.
So I have to convert this number to a string.
Yeah, you have to put it in literals somehow. So, is that right? I don't know. I don't do it that way, so I'm not sure. Yeah, I don't know. We'd have to look at it. Come to office hours sometimes we can see. Other questions? Yes, sir. The header line is like the one in the file. There's going to be one thing for each column, and one label, and the label might have more than one word in it. So, yeah. So you're probably asking how to read the header line since you don't know how many things are going to be there. Get line. Yes.
The order in which all the values show up in each line is the same as that.
Yes, the order of the columns will always be the same. If I wanted to be like a big jerk, what I would do, yeah, you'd have to read the header line and then figure out which column was which and then read it in the right way. I wouldn't even want to do that. That would be horrible. So, yes. Yeah, we'll learn how to do that today. And we'll learn how to format neatly today. So. Other questions? Yes, sir. Header line will always be there. Other questions? Nothing? Going once, going twice? Because you know I won't answer any more questions after this during class, right? Once I start going, I'm unstoppable. I'm kidding. Okay. So last time we talked in way more detail than I meant to about file I/O, how to read and write from files. So we went over that pretty clearly. What was fstream? It's the library that we need in order to have ifstream and ofstream. What is the difference between getLine and angle? The little angle brackets? Yes? It'll grab anything between space. It'll, figure out the longest thing it can do, right? So getLine will get the whole line, and if you use angle, if you have formatted input and output so that there are clear breaks between things, you can trust it to reliably get the separate pieces, right? And we saw how CN failed. It does all sorts of weird stuff, and it seems like we did a lot more last class, but that's kind of the topics that I had listed. So we'll just go back and take a look. This is the program we were working with last time. It's called File I/O. It's uploaded onto Blackboard if you wanted to play with it yourself. I was just going to look through this very briefly and point out some important parts and revisit one thing that I had some questions on, and then I'll show you one more thing and we'll move on to another topic. So we're going to be reading and writing from files. So we need what to read from a file, what type of variable represents an input file, ifstream, and what represents an output file, and what represents a decimal number. Okay, just checking. Okay, so we have an ifstream and ofstream. We read in the file name for the input file, and we call open, and we have to do something weird when we open it, which is we have to convert it to a C string. This makes me sad, but we do it anyway. Then we can check and see if the file opened correctly. If not, we jump out. Same thing with the output file. Read in what the file name is, try and open it. If it does not open correctly, and here I use the .isOpen, which is just a different way of doing the same thing, right, up here, you say it wasn't opened. Finally, we start reading. The first thing we have to do is get rid of the header line. And the only way that we have right now to get rid of the header line is to go ahead and read it in. Once we've read it in and we store it in that variable, header line, what do we do with it? Nothing. We just ignore it forever. We just put it aside and get it out of our way. Then we have kind of our standard way of reading a file. While input file into int1, int2 letter decimal, because that was the data file we had. Each time this loop succeeds, we will increment the line count by 1. That means we successfully read one line. And then we will output what was in there. And then we will also output to the file, right? Cout, when you see cout, you should think computer screen. When you see cin, you should think keyboard. And then output files. And then when we're done, we output how many lines the file had. Question, yes?
So cout is going to print stuff on the screen.
Yep.
And output file is going to take that and store in a file.
Yep. That's exactly it. And we can't do both at once. We have to have a separate line for each, right? If you want to write to the file, you use angle on the file. If you want to write to the screen, you use angle cout. Yes, sir. I did not. So the line count for this is I'm just counting the number of data lines that were in there after we got rid of the header. You're not going to want to count the header line as a line in your program because when you compute the average, you need to know how many lines you read, and you want to divide it. So this is exactly how I counted the lines in my project, which I already said stinks, but I think this part was right. It's up to you. If you count the header line, you will have to subtract it out again later in order to do the average correctly. I have two answers for you. Magic. And the second is that I'm just going to go with magic. Can you just say magic? Are you willing to accept that? Okay. That's the easier way to explain it. Yes. Uh-huh. Okay, so if you only want it to count lines that are good, then you have to make sure that where you do the increment only happens after it's done all the checking, and if there are bad lines, it doesn't happen. Does that make sense? So if you only want to count the good lines, then you have to make sure that you increment it only in the case that the lines are good. Everybody good on this? Okay, so this file is on Blackboard. You can download it and play with it and look at the code and do whatever you want with it. Now, one thing I want to add to this is one more thing. Sorry. I don't know what that, okay. What normally happens is we open a file, and then when we're done, we close the file. Now, I haven't showed you how to close the file because we don't strictly need to do it. And the reason we don't strictly need to do it is after we're done here, we return, and that exits the program. And the files automatically get closed and cleaned up when the program exits. Does that make sense? But if you ever have a program, like, I don't know, Project 3, if you ever have a program that opens a file and then continues running after it's done with the file, you need to close the file. Does that kind of make sense? So it's kind of like you're opening up to read from it, and you close it later. The reason you need to close it is kind of weird. Sometimes you can get away without closing the file, but operating systems vary in how many files you can have open. You can typically have a few hundred or 1,000 open at the same time, so you would never notice it in this class. But if you're ever writing larger programs, you can run out of open files, and you just can't open anymore, and then your program dies, and it's sad. And in fact, in my research life, I'm dealing with this situation right now. I have a file leak, and if my program runs too long, it reads millions and millions and millions of files. After a while, it cannot open anymore, and it dies. And it's really annoying, and I can't find the bug. So we want to close the file. And the way we do that is pretty easy. Input file, dot close. And that's a method. And output file dot close. And what this does is you say, hey, I'm done with the file. You don't need to keep track of it anymore. Does that make sense? What's the matter? Sorry, I cannot hear you back there. Oh, output. Okay. All right. Does that look better? Let's just go ahead and compile this and see if it works. That's weird. All right. So go ahead and compile this. No problem. It accepted the close, and now the program's been closed. You're not going to see the difference very often on this, but it's actually important later. In this class, it's not important, but you need to know about it. All right, any last questions about reading and writing from files? Going once, going once. How many already wrote the code that does the file reading and writing? Yeah. How many of you have not? How many of you have not and you're just not admitting it? How many of you have arm injuries today? How many of you are happy? How many of you are sad? There's like that section of the class. I'm just not reaching you. Can you hear me over there? How many of you can hear me? Oh my gosh. How many of you want a piece of candy? Ah, okay. Now it's working. Here. See what I got. Ah, Three Musketeers don't go very far. They're too light. So. Back into the code? Like right there? There? Okay, it's uploaded. The only thing that's not uploaded is these two lines. It's not? All right, send me an email. I'll fix it after class. Okay. All right, so we're going to move on now. So obviously, some of you looked at my program from the bad program that I wrote that does stuff that is kind of buggy. One thing it does do, though, is it kind of outputs the data kind of nicely, right? Okay, I feel like a little adversarial here today, but let's see. I'm just going to ignore it, and I will keep talking, and I won't even look at you, and then I won't know. Okay, so what we're going to do now is we're going to look at how to improve our output formatting. Pound include IOStream using return 0. All right, so here's our little stub of a program, and what we're going to do is we're going to output a few things. Let's output an integer 5. Let's output a double. And let's output a character. Anybody have a favorite character they like? All right, so you said P. All right, so we have these things. And we know how we can output them, right? We can just see out integer. And we can see out real. And we can see out character. And we can see out some sort of string. It's like a word. All right, what is this going to output when we run this program, assuming it compiles correctly? Yes? Yep, so what's the output going to be? Okay, so it's going to be all jammed together. Is that what you expected? Turn up the fun on this. I'll run that again so we can see. So everything was jammed together. This is annoying, isn't it? Yeah, it's ugly. Let's look at how we can make it neater. How can we make this neater? We can manually add spaces in between. Okay? Let's say that we wanted these things to be nicely formatted in columns of the same size. Does that make sense? How do we add the right number of spaces for that? We can just add spaces, right? The thing is that here, say we wanted our integer to always take up 5 spaces. How many spaces will we add? And what happens when we change the integer from 5 to 25? How many spaces do we add then? And what if it's 125? So how many spaces do I have to add? A variable amount. And so we don't easily know how to add the right number of spaces, right? But there is a way that what we can do is make things prettier. So there's a special library that we use. It's called IOmanip, short for input-output manipulation. IOmanip. And what it will allow us to do is to do some formatting. So the easiest formatting we can do is what's called setwidth, SETW5. And we just insert that just like anything else. Now what this says is, as we're reading it, it says, okay, we're going to output something to the screen. And when you see setwidth, SETW, which is called setwidth, this does not get printed to the screen. It just doesn't. Instead, what it says is, it says, hey, something is coming right after me. The next thing that comes right after me, make it 5 spaces wide. Okay? So, any predictions on what this code's going to do when we run it? How many spaces? 4. That sounds like a good guess. Let's try it and see. It compiled cleanly. We run it. And we have some spaces. And we can actually count how many spaces they are, because everything, it's a monospaced font, so each space is the same size. 1, 2, 3, 4, and then the integer 5. Yes? Yes. You can. There's a whole bunch of stuff you can do. I'm not going to show you everything. Okay, the question was, can we make the space after the 5? And the answer is yes, I think we can, and I think we do it by doing this. And if I'm wrong, okay. So here's what I did. Before, the 5 was all the way on the right. If you want it to appear on the left of the column, you just use the word left inside there. And you can see I added left to that. The first time we ran it, it was these 5 spaces, and the 5 appeared on the right side. The second time after I added the left, it was 5 spaces, but the number appeared on the left side of the column. Okay. I didn't really mean to teach you that, but I like answering questions, so. All right, everybody kind of see how this works? Now, what's interesting about this is that notice set width only affected a single variable, right? Set width only affected a single variable. I'm going to go ahead and take this left out, but you can use it if you want. And which variable did set width apply to? The integer. What do you think we have to do if we want to format the other columns to a particular width? We have to do set width a lot of times. That is absolutely correct, and it's kind of annoying, but what can you do? So let me go through. I'll put some more set widths in here. Man, I wish we could have movies. Maybe we should just like watch The Matrix one day. That'd be easier for me. Okay, so I've added a bunch of set widths. This was the original one that was there for the integer. This one's for the real. This one's for the character. And that one is for the string literal word. Okay, what's going to happen this time? Yeah?
Is there any reason you did the last one as 15?
I just felt like making it bigger. That's all. How big do you want it? We can do 5. Doesn't really matter. So the question is, what happens if we make it too short? Right? So we'll use 7 right now. Everybody see what we're talking about? Set width 5 integer, set width 5 real, set width 5 character, set width 7 word. So what this says is print this in a column of, print the integer as a column of 5, print the real in a column of 5, print the character in a column of 5, and then print the word in a column of 7. Everybody with me? So let's compile this. It compiled cleanly. We'll run it. And here's what we see, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So since the real was 3 characters, 4.5, it put 2 spaces in front of it. P, it put 4 spaces in front of it. And word was 3 characters, and it was supposed to be 7, so it put 3 spaces in front of it. This should be pretty straightforward, right? Everybody good with this? All right. So the question is, what happens if we make this a really long word? Right? Before, word was only 4 characters, and we put it in a field of 7. And now we have, 12 characters in a field of 7? Any guesses what's going to happen? Yes. It'll what? It'll die? It'll crash? It'll cut it off? Anybody want to guess? Truncate it? Think it'll truncate it? What do you think? You just think it'll overflow? All right, so we have our choices: die, truncate, or overflow. Okay. How many of you think die? How many of you think truncate? How many of you think overflow? How many of you have no opinion yet? It's perfectly reasonable. None of the above. Let's find out. I have an idea. All right, it compiled completely. We run it, and here's what happens: is it just overflows, right? It doesn't cut it off. It just, if it's too big to fit in that area, it just puts whatever it has there. All right. All right. Everybody with me? Pretty straightforward, right? All right. So let's change this up a little bit. Let me just do one thing here. All right. All right. So we saw how set width worked. Oops. Now I'm going to write another program. Okay? And this is going to do a little bit of formatting that we can look at. So let's say we have a couple of numbers here. Let's call it double pi. And what is pi? Anyone else? I don't know. That's close enough. How about Euler's number? There we go. Okay, so we have some long decimal numbers. What's going to happen when we try and output these things? All right, any predictions here? When we print out pi, what is going to print out? Tell me explicitly exactly what numbers are going to print out. Okay. And when we print out E, what's going to print out? 2.7818281828459045. Let's try it and see. So I created this new program, precision.cc. Precision. It compiled cleanly. Let's run it and see what happens. Well, I didn't put a space between them, right? Which I did on purpose. But let's go back and figure out how to put a space between them. How do you want to format this neatly? Sure, 20, that's fine. All right, so now we've given plenty of space, right? There's any things, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's 18 characters long. It should fit in 20 neatly, right? All right, so now they're not going to be jammed together. We'll compile. Whoops. I think it would help if I had iomanip in here. Now it will compile. And now when we run it, we should see all these decimal points, right? 3.14159, 2.18, 2.71828. All right. You're asking yourself, what is going on, aren't you? You should be. Good. I'm glad you're answering. So here's what's going on. By default, when cout prints something, it prints 6 digits. Actually, it prints 7 characters. By default, it'll print 7 characters. All right? By default, it will print 7 characters. So what's happening is when it prints things out, it is printing 7 characters. 1, 2, 3, 4, 5, 6, 7, including the decimal point. So let's add one more number just to show you that this is what's happening. I'm going to call this one big, and this one's 120, 1237.98. There. And we will also output big. And we will make this 20. So now we're printing out these different numbers. I added another one that's in the thousands and has some decimals. Compile, it compiled cleanly, clear it, and we will run it. And you can see, even though we only had a bunch of decimals, it prints out 1, 2, 3, 4, 5, 6, 7 characters. By default, any decimal number that you print out prints out 7 characters, including the decimal point. Including the decimal point. All right. Anybody know why it does it that way? Yeah. Yeah. Yeah, the answer is I don't know why it does it that way. They just, whenever they designed the language, that's what they did. Beats me why it's like that, but that's why it is. Do we always want to print out 7 digits? No, sometimes we want to print out a varying amount, right? So here's what we can do. We can add a line, and here's what I'm going to do is I'm going to show you how this works by duplicating this line and doing this. Here's what we're going to do. We're going to add a thing called set precision. And how many decimal points do you all want to show? 2? Clean this up just a little bit. So we added this thing that says set precision 2. And again, this is one of these tokens that you can insert using this angle operator. It doesn't print that out. It's not a variable. It just interprets it to say set precision 2. Any guesses on what's going to happen now when we run this program to the second line of output? What do you think is going to happen? Yeah? So you expect 2 decimal places to show up, right? Pardon? Well, set precision 2. I'm just guessing. I'm just asking you what you think it's going to do. Yeah. Okay, you're expecting 2 decimal places after the decimal point. Is that right? Let's try it and see. How many of y'all want to try it and see? Let's try it and see. Compiles cleanly. We run it. And here's what happened. Remember, by default, cout will show you 7 characters. 7 characters, or 6 digits, right? If we set precision 2, we're telling it we want to see 2 numbers. And so it's going 2 numbers. So it's essentially either rounding or truncating. And if the number is too big to be displayed in 2 characters, it resorts to scientific notation. Well, how about this? Let's figure out where we can. I don't know. Let's just for fun right now change pi to 3.99. How's that? Even though that's not pi, we can just give it a shot and see what happens. It rounds. So it rounds. All right. This is not what we want to have happen, is it? Set precision says how many digits to display, and instead of 6, it made it 2. What we really want is we really want the number of decimals to always be the same. And there's a magic command that does this, and I will show you right now. It's called fixed. What fixed does is it says, hey, when set precision happens, don't affect the number of digits that you're showing, affect the decimal places only. Actually, let me take this back out and do it this way. So I'm going to create yet another line of output, and I will add fixed. Now, one thing about set precision is unlike set width, each time set width affects something, it affects only that one variable. But set precision, once you use it, affects everything forever and ever there and after. Okay? Set width only affects one thing, set precision affects everything. And when you do fixed, it will actually make it work the way that you want, which is to show the right number of decimals. Yes, sir? Nope, set precision lasts forever and ever. Yep, once you've used it once, it stays the same until you tell it to do something different. So set precision, if we just have a big integer, won't actually make any difference. It'll just display the whole integer. It'll just show the whole thing. But in essence, I'm just showing this because in order to format your output to be neat, you're going to want to do something like this. Yes, set precision by itself shows how many digits to display. By default, it's 6. And then fixed says, hey, change that set precision from working on the number of digits to just working on the number of decimals instead. It's a weird behavior. Yes? Yes. I used it in mine. And in fact, the very first thing I do in my program is I have something that says cout angle fixed angle set precision semicolon. And I have that at the very top of my program, and I do it once, and it sets all the output for the rest of my program to be 2 decimal output forever and ever. Yes, sir? Uh-huh. I know. Let's try it and see. So the question is, what happens if we go beyond the number of decimals we have? So set precision 10. Let's set precision 10 up here too, so we can see the difference between what fixed does or not. Okay? So I set precision to 10 on both of these. We compile it, we run it, and it's going to give you as many decimals as it has. So on this line, where we did set precision 10, it just printed out as many decimals as it had, right? It didn't print out everything. But once we said fixed, if it printed out, it would also pad it with zeros.
Then doesn't that mean for your program that things are printing out without 0, 0?
Yep.
Isn't that annoying?
Nope. Yes. Okay. So this line right here, let's look at this line right here is set precision. And this line is set precision with fixed. By default, when it prints out a number, it prints out 6 digits. 1, 2, 3, 4, 5, 6. And a decimal if needed. If we say set precision is 2, by default, cout will print 2 digits and 2 digits only. Yes, exactly. But, so set precision changes the number of digits it shows. But we don't really think in digits, right? Like when you think of a number, how many of y'all think how many digits that number is? I do. That's my paycheck, right? That's important to me. But most of the time, we don't really think how many digits are in there. So it's this weird thing. Set precision just says how many digits of the number to display, which isn't how we think. But if you use fixed, it changes set precision to say, hey, instead of how many digits to use, how many decimal places to show. Yes? Uh-huh. No. This only is the display. It has no effect on the internal math. It's only when it prints it out. So it doesn't change how the computer handles the numbers. That is defined by the type, whether it's a float or double or long.
Could you say again what that command was that you said?
Yep. So here's what I do for my program. When I want to set things, I just do this: cout angle fixed, angle set precision 2. Like that. And I do that at the beginning of my program. And if I do that, what you're going to see now is if I compile it and run it again, that these things come out as 2 decimals, which is what we expect, even though they're on a different line. And these things just do other weird stuff because we've done other set precisions in there. But this is the line that I add at the beginning of my program to just set the decimal places before I get too far into it. Yes, sir? No, it only affects floating point numbers. So integers don't display any decimals. Yes? No, it cannot. Set width will apply to string, but set precision will not. And if you're saving decimal numbers in a string, I would suggest that you might want to rethink your strategy. That is not a good way to do it.
So, I just want to get this straight.
Mm-hmm.
After you do this, if you do it at the top of your program, you don't have to use fixed or set precision.
Ever again. Once you've done it once, it affects the behavior of cout forever. You still have to use each set width individually, though, if you want to format the width. Yep. Yes. And so anything we can do here with cout, we could also do with ifstream or ofstream, an ofstream object for a file. Yeah. Why don't you ask me later, because I'd have to look at your code and see what you're doing. But in general, if you're doing numbers and calculations, you should be using a double because you can't like divide strings or multiply strings, right? Talk to me later. Yes? It does, absolutely, right? So here we set precision 2, and if we look at the output, right, we see we had 2 here, but then we did the set precision 10, and it changed it all.
Why did you need to put it, can you go back?
Yeah.
Why did you need to put it so that, the first time had set position 10, why did you need to put it again?
I didn't need to put it again. I'm just doing this for class demonstration purposes. What I normally do is I have this at the beginning of my program someplace, And then all the other output, I don't ever use set precision again. But if you want to, you can override it by using set precision elsewhere.
But if you say you didn't have fixed at the top, if you just had fixed later on,
Uh-huh.
then that's when the fix would start applying.
Yes, exactly. So if you had set precision at the top without fixed, it would affect the number of digits that were displayed, not the number of decimal places. And then later, if you threw fixed in there, it would change the behavior. Okay? Okay. These make really tricky, horrible exam questions, by the way. So depending on how mean I'm feeling come exam writing time. All right. I've been talking for a really long time. Let's take a 1-minute break, shake it out, stretch, do what you need to. All right, welcome back. How y'all doing? Is it like midterm time or something? Oh, that doesn't bother me. Okay, so any last questions on formatting? Right? Any last questions? Set width does what? Yes, it does. And what does right what it says on the label? Sets the width of the next thing. What does set precision do by itself? Sets the number of digits after the decimal point? The total number of digits, yes. And what does set precision do after you have put fixed in front of it? Yeah. All right, everybody good on that? And you can mix them up stuff. So, all right. Good. So that's pretty much what you need. That's the last piece you probably need for the project to get your formatting nice. When you output are those little things. Yeah?
So neither fixed nor set precision works on characters.
Yes, these only work on decimal numbers.
Okay.
Only work on decimal numbers. Yes, sir.
So you need set width for every single number.
Yes.
Set precision, you only need one.
Yes. Set width has to be in front of every single variable that you want to set the width of. Set precision and fixed you only ever need to use once, and they will continue into operation until you override them with something else. Continuing on the theme of magic, I'm going to go with like Merlin or Gandalf or someone, whoever the big wizard was who wrote the language. Yes? Yes, and in fact, if we have fixed without set precision, what's going to happen is we're going to get 6 decimal places because set precision by default is 6. Let's just try that really fast and see. Because I said that like I sounded like I knew what I was talking about. But I didn't, so fortunately we can ask. Yep. So now we're getting 6 decimal places. By default, the precision is set to 6. And if we say fixed without changing set precision, we will get 6 decimals. As you can see in the top line. These other lines are confusing because we set precision to 10 on those. Okay. Any last questions? Yes, sir. Set precision only applies to decimal numbers. It does not apply to integers, characters, or strings. We can try it really fast and see. I don't believe so. Okay, so I added the integer to our first line. It's after the fixed and set precision. We can compile it. It compiles cleanly. We run it. And set width went past the end line, but it did not display any decimals. So set precision does not add any decimals to the, with fixed, it doesn't add any decimals to the number. Oh, without fixed? Let's take fixed out then and see what happens. So integers, it's all about floating point numbers. Okay. Take that. Yep. Yep. As far as I know, maybe there's some other weird cases that happen because that happens, but as far as I know. Okay. Yes? No. If your integer is bigger than the number of things that precision says, it will overflow and print the whole thing. Yes, so it's 6 digits, a decimal point, and it's needed by default. But if in order to display the number, it'll display it. I mean, we can try it here. We have an int here. Let's 5, 6, 7, 8, 9, 10. Okay, and we'll comment out fixed and set precision. Right. So now we're just displaying 6 digits by default. That's what set precision is. Right. So our number is very big. We've gotten rid of fixed and set precision for the first line. And we're printing out the number. So we'll compile it. It compiles cleanly. We run it. And you can see it wrapped around, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. It printed all 10 digits. So for integers, it will do that. And if we do something like, if we want to just try set precision 2 now, if we want to like ramp it down a little bit, compile it, run it, and we're still getting all 10 digits because set precision only applies to decimal numbers, not integers. Okay? But you'll notice that our other big number, because it was a decimal number, it was a double, it got converted to scientific notation. Does that help? Okay. Yes?
Is there any way of
Yes. Yes? There is. There are functions in the math library, and you can explicitly call like round, or ceiling or floor are the functions. So round will round kind of like you expect. Ceiling will like truncate, and floor, I can't, any math majors here? I can't remember which is which, but you can look and see. But there are explicit functions for rounding if you want to round the number. No. Mm-mm. Pardon? Yeah, ceiling rounds up and floor rounds down, I think. Yeah. So. Okay. I like this class because you have questions, but it means that sometimes we go a little bit slower than we need to. You ready for something new? Well, you don't get it. Here's what I'd like to do is we talked about while loops briefly. What did we talk about while loops for? For reading files, but it turns out we can use them for a whole bunch of other things. Okay? While loops are very useful, and a whole bunch of different loops are useful for other things. So let's go back and revisit the structure of a while loop. Here's how a while loop works. We have the word while, a parenthesis, then we have some sort of Boolean expression, a curly bracket, a closing curly bracket, and we have something inside here which is called the body of the loop. Okay? And I just wrote this as a comment so we can think of it as just a notation as how we talk about while loops. So we have the word while, open parentheses, some Boolean expression, And I'm using these angle brackets to indicate something that, we can replace. And I didn't close my angle brackets. Open parentheses, the body, which is what gets executed inside the loop, and then close curly brackets. All right, does this make sense? So we've seen this before in file reading, right? We have while input into a whole bunch of stuff. The body is do whatever computation we want, and then we're done. So let's say that we wanted to have a while loop that printed out all the numbers from 0 to 100 in increments of 5. How'd you like to do that? Yes? One thing we could do is we could do cout 0, cout 5, cout 10, cout 15, yada, 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 and that would suck, right? How about if we wanted to print out all the numbers from 0 to 1,000,000 in increments of 5? Cout 0, cout 5, cout 10, yeah, it goes on forever. So loops are very, very useful for doing repetitive things. So for example, we want to output all the numbers from 0 to 100 in increments of 5. Well, we need some sort of variable. We can start at 0. And we can say while count is less than or equal to 100. What do we do? Cout count NTL and count plus plus. Yeah, if we want to go by 5, we can say plus equals 5. What is this loop going to do? Yeah, including 100 and including 0. So let's see if this works. 0, 5, 10, 15, 20. That looks pretty good, right?
Wait, so why did it do that? Because the count plus equals 5 came after.
Okay. So let's step through this code and actually look at how it works. If we want to step through code and read code to see what it's doing, where do we start? Where do we start? This was day 2, remember? Int main. Int main, we always start reading at int main. The computer is stupid, but it's stupid very, very fast. And all the computer does is says, I'm starting here, int main. Do nothing, that's a comment, that's a comment, the comment do nothing. Int count equals 0. What does this do? It declares an integer named count that and initializes it to 0. So now there's a box of memory that has a 0 in it and the name count associated with it. Now we reach this while loop and we say, aha, while count is less than or equal to 100. Is 0 less than or equal to 100? Always? Close enough for us, yeah. Okay, so cout angle count, and when it sees this count, what does it do? Runs off to that box labeled count, finds the number inside, which is 0, prints it out, ends line. Now it says count plus equal 5. What does this do? Adds 5 to what's in count and puts it back in count. So it finds the box named count, takes the number out, which is, adds 5 to it, which makes it 5, puts it back where? Into count, and then we're done. When we hit this curly bracket, because it's a loop, we automatically go back up and re-evaluate this Boolean condition. Automatically. All right, we reach the end of the body of the loop, we go back up and re-evaluate this. All right, what is the value of count right now? 5, because nothing's going to change it. Once we've stored it, it's not going to get changed. We go back up, count is now, it's 5, right? We made it 5 down here, it's going to be 5 forever unless we do something to change it. Or somebody trips over the power cord. But either way, it's going to be 5. Actually, not if you trip over the power cord. So, what is count? What is count? All right, is 5 less than or equal to 100? So we keep going again. What do we print out? Count is 5, plus equal 5 makes it what is now stored in count? We go back up here, we evaluate. 10 is 10 less than or equal to 100. Does this get tedious? Let's skip up to 100. Is it going to be 100 at some point? Okay, so is 100 less than or equal to 100? What do we print out? 100 plus equals 5 makes it. We go back up. Is 105 less than or equal to 100? So when that happens, we automatically continue past the bottom of the loop. The next statement we hit is, and this means, and we stop. Yes? Remember, this is just a box in memory somewhere that has a name assigned to it. Every single time the program sees this word count, it's going to go, oh, they're referring to that box over there that has something in it. This, yes, once this line of code is executed, it is never going to be run again, right? Because it's not in a loop and we only go down unless we hit a loop that sends us back up. If we had count included, so the question is, if we had put this int count 0 inside the loop, what would happen? Yeah. So if we put the variable inside here, let's just step through and see what would happen. Int main, nothing, 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 nothing. Oh, while count less than or equal to 0, what would happen here? Compiler error, because it doesn't have any idea what we're talking about. All right, let's take that int count each other. Okay, while count is less than or equal to 100, is 0 less than or equal to 100? And it says int count 0, what would happen here? Compiler error. And the reason is because we already said there's an int count, and we're trying to create a new thing called int count. And the compiler goes, hey, you can't have two things with the same name. So let's take that out. Okay, now it should compile. It says int count equals 0, while count less than or equal to 100. Is 0 less than or equal to 100? Set it equal to 0. C out, what gets C out? Count plus equal to 5, it was 0. What's 0 plus equal 5? Yep. We go back up. Is 5 less than or equal to 100? What do we do here? Count equal to 0. What do we output? Do you actually believe that's going to happen? Let's try it and see, just for fun. Yeah, you can kind of tell it's still running because the cursor flickers a little every once in a while. So how do we stop it when it runs away like this? Control C. Okay. All right. So this is in general like how a loop works, right? Let's make sure what else we have. Reading from files. All right. Everybody good on this? This is a loop. A loop has a loop, what's called the loop condition, which is the Boolean expression, and the body of a loop. Let's say, I don't know, what else do we want to do? Counting things, by the way, is super common, and incrementing things like this in fixed steps is also super common. All right. Let me take this count out here, and that is, we're back now to having a loop that will count in increments of 5 from 0 to 100. Yes, sir? Okay. The while loop is actually one loop of 4 that exist in C++. There are 4 different types of loops. Okay? The while loop is one of them. The while loop is useful if you don't know that you always want to enter the loop. Let me say that, what happens if up here I make count 200 to start with? Count is 200, we say while count is less than or equal to 100, output stuff. What's going to happen? Nothing is going to happen because the loop will say, oh, 200, is 200 less than or equal to 100? And the answer is no. So the loop never happens. It never happens. So so loops don't necessarily have to, a while loop doesn't have to happen. There is another loop called a do while loop. And the difference between a while loop and a do while loop is that the do while loop will always run at least one time. Okay? Always run at least one time. And a do while loop looks like this: do and an open parentheses, open bracket. Then you have the body of the loop. Then you have the word while and the Boolean expression. And then a semicolon. Okay? Sorry. Ah! Stop it. Sorry, I have all the security software on there that gets in the way. Oh, come on. Okay. So let's look at this loop. So this loop starts at count 0. Is 0 less than or equal to 100? Yes. So what does this loop do? It goes through until. When we're done with this loop, what is count going to be set to? 105, right? 105. If we go down here and we keep running, it's going to say do cout count. What is this going to output? 105. This is going to make count equal to. And then the while loop says, oh, while count is less than or equal to 100. Is 110 less than or equal to 100? No, so it will exit. If count were less than 100, it would go back up to the curly brace and do it again. So a while loop has the condition at the top. A do while loop has the condition at the bottom. So a do while loop will always run at least one time. Always run at least one time, no matter what. A while loop may not run. Yes?
So why are the curly brackets like that? Because usually I would think that the curly brackets would end after the while.
Because the curly brackets here are enclosing the body of the loop, and the curly brackets are what we use to combine a whole bunch of code into the equivalent of one block or one statement. And so the curly brackets here are used to surround the body. And that's just kind of how it works. With that. So, should we run this program and see if it does what we think it does? Let's try it and see. We compile it, we run it, and here we have all the numbers from 0 to 100, and then we also have 105. And the reason we have 105 is because this do while loop executes once, even though count was bigger than the condition at the bottom. Okay, so a while loop doesn't necessarily execute, and a do while loop always executes at least once. Everybody good? Yes? There's one more kind of loop that I will show you today. One more kind of loop. And this loop is used much more frequently than the other kinds of loops. How many of y'all have programmed before? How many of y'all use for loops much more often than while loops? For loops are really the most common. And here's how for loops work. So this is kind of the equivalent of the while loop we wrote before. For loops look like this. And I should have just actually done it this way. You have the word for, you have an open parentheses, you have an initial condition, you have a semicolon, you have a final condition, you have a semicolon, and you have what we can just call an incrementer. Then you have a curly bracket, you have the body of the loop, and another curly bracket to close. Here's what happens. If we want to deconstruct this loop, this for loop, into the equivalent of while loop, it looks like this. Initial condition gets put on top, then you have while, You have the final condition. As the expression, you have the body of the loop, which is the thing that it's doing over and over again. Then you have included at the very bottom of the body what we're calling the incrementer. So these two things are equivalent. All right? The for loop is just a convenient way to create a loop that will do something a particular number of times, all in one convenient notation. But other than that, they are equivalent. Okay? So if we look at the construction, we have a for loop, we have an initial condition, and here our initial condition is to declare a variable named int count and set it equal to 0. The initial condition is something that will happen every single time. We have a final condition, which is the same as the Boolean, which says if this is true, do it. And we have the incrementer, which happens at the end of the loop before we go back up to the top automatically. And in this case, I only incremented count by 1. If we wanted to make it exactly equal to the other program, we would do plus equal 5. So this is a convenient notation for a loop that will execute a predictable number of times. Yes?
So, is there a preference for for and while, or just while? I know you said while is
Okay.
you don't even know if it's
So which one do you want to use? You want to use a do while loop if you are sure you want the loop to execute at least one time. Right? If you always want the loop to execute at least one time, the only way you're guaranteed to get that to happen is if you're using a do while loop. The difference between a for loop and a while loop is that while loops are commonly used if you're going to loop a number of times and you don't have like a particular number of times in mind, right? Like you use a while loop if there's going to be an indeterminate number of lines in a file, if whatever you're doing, you just don't know how long it's going to take. Typically, you use a for loop if you want it to execute a certain number of times. And we're going to see for loops in the future. We're going to be using them more, but you're going to see the for loops executing a certain number of times. Does that make sense? Now, in fact, for loops and while loops are really equivalent. You can rewrite them very easily. And do while loops can be made into while loops if you just put an if statement in front of them, right? They're all kind of equivalent. Yes? Yeah. You could. If you knew the number of lines you wanted to read out of the file, you could have a for loop that read that many lines. Absolutely. And sometimes, sometimes file formats, like I could give you a file that instead of a header line had an integer, and that integer was the number of lines in the rest of the file, and you could read that and then just read all the rest. And some files work that way sometimes. Yes?
All fours can be converted to whiles and all whiles can be converted to fours.
Yes, absolutely. Right, and this is essentially the mapping here, right? This is the mapping here. I would suggest as a stylistic thing, if you are going to have something that I don't know, just develop your own style. For me, I use for loops if I know how many times I want it to execute, and I use while loops if the number of times it's going to execute is indeterminate. Some people use for loops even though it's going to execute an indeterminate number of times. I tend not to do that. So. Yes, sir. All right. Let's just run this. Do you all want to see this if this actually works the way that I claim it does? So let's just compile this and see. I kind of don't want to show you bad things. I kind of don't, right? I mean, I could show you how to use a for loop to read a file that looked almost exactly like our while loop, but I don't want to do that because even though it's possible, it's like a bad way of doing it. So I'd rather just show you good things as much as possible. Sometimes I tell you bad things to warn you about them. Like, what is a tool of the devil? Do you remember? I talked about this. It's an operator, single character operator. What? You've forgotten this? I have failed as a teacher. The question mark operator is a tool of the devil. Tool of the devil. I use it sometimes, but it's a tool of the devil. All right. Pardon? Well, other people use it, and you need to know what's there, but doesn't mean you should use it. Okay, so we just ran this. We saw it counted from 0 to 100. We were all very happy. How many loops did I say that there are? How many have I shown you? You don't get the fourth one today. Because the fourth loop is it's a particular circumstance, and I haven't introduced the other stuff that you need for that particular circumstance yet. So I can't show it to you without teaching you other stuff. All right. Cool. So I think that's about it for today, even though we have 2 minutes left. Anybody want to ask any last minute questions about the project before we go? Yes? My office hours are in my office, which is St. Mary's 323. St. Mary's 323. And I'll be there at 1. I normally get lunch along the way, so I should be there. Thank you for coming. Have a good Wednesday.